Swayam Prabha. Digital India. Educated India.
Now, this is important. So, if we have yarn number, yarn count, or yarn linear density value, can we predict the yarn diameter? So, we know that coarser yarn, like for if you take English count any, so higher is the value, that means yarn diameter will be finer. Lower is the value, yarn diameter will be coarser. And the count or linear density is the factor which affects the both length and mass of material, length and mass relationship. But actual appearance, which is controlled by the diameter, that means compactness, closeness, cover factor, where the yarn diameter is important. Now, one general relationship can be derived, and which is not valid for every situation, but what we have to do, we must know the condition. So, first we have say one particular condition. The condition is that this should be cotton yarn, one cotton yarn, and experimentally for normal twist level, experimentally it is observed that average void content in ring spun yarn is approximately 40%. So, the relationship which we are going to get, which we are going to derive, the diameter relationship, this is only with the assumption that 40% of the yarn in the volume itself with void content, and it's a ring spun yarn. That means void, this 40% void content can be increased or decreased. So, if we increase the twist, this void content will reduce. So, relationship will change. So, with this condition, 40% void condition, that where you have solid content 60%, void 40% void means solid content is 60%, and density of cotton yarn 1.54. That is the assumed, this is the approximately 1.54, 1.53. This is the cotton density, and if we consider these two, then specific volume of ring spun yarn will become approximately 1.33 cubic centimeter per gram. So, if we take 1 gram yarn, 1 gram yarn with certain twist level, 1 gram cotton yarn with certain twist level, that resulted approximately 40% void. In that case, so 1 gram yarn, this volume of this cylindrical shape, considering the yarn is circular, this shape will be 1.1 cubic centimeter. So 1 gram yarn if we take, that will be, so that's with this condition one can derive. It is simple relationship. 1.1 comes from this and 60%. 60% solid content, and from there we can get this relationship. So mass of 1.1 cubic centimeter yarn will be 1 gram. Now if we know the diameter as D, so from this volume we can calculate the, and if we know the English the count, say English count or text, we can calculate the length of the yarn in 1 gram. 1 gram yarn, the length and length of the yarn we can get. So volume of L length of yarn will be, if D is the diameter, pi D square L by 4. L is the length of the yarn, D is the diameter of the yarn. So for N text yarn, mass of 1000 meter yarn weighs 80 gram. So that from the definition we know. And then length of 80 gram is 1000 meter. Similarly, 80 gram length is 1000 meter. So length of 1 gram yarn will be 1000 by 80 meter. So this length we have calculated, 1000 by 80. Length is calculated. From there we can calculate the volume. So length of 1.1 cubic meter, 1000 by 80. So volume of this 10 to the 1000 by 80 meter, that means 10 to the power 5 by 80 centimeter. This much centimeter length of yarn is this one. This by L. So that we have already discussed earlier. So this L, pi D square by 4 multiplied by L, L we have calculated. This is the L. So total volume will be cross section area multiplied by L, which is 1.1 cubic centimeter. And by rearranging this equation, we can get D equal to 0.375 by 100 multiplied by under root NT, it's in centimeter. This is the relationship for yarn diameter in centimeter with the NT. If NT is given, means text count, text linear density is given, we can calculate the yarn diameter, and only condition is that this yarn should be cotton yarn and with the specific volume is 1.1 cubic centimeter per gram, okay, and this has come with a 40% void content. With this condition, if we change the yarn twist, if we increase the void content, this relationship will entirely change. And the relationship with the English count system, we can convert this NT to English count. Here you can see, just we replace this English count system and we get this relationship. If we just simply solve this data, we will get 1 by 10.97 under root NE. This is in centimeter. And if we convert it to inches, you multiply it by 2.54 here, so you will get approximately 1 by 28 under root NE inch. So this relationship is very important. We can use to get the approximate diameter of yarn. And for cotton yarn, this 40% is the normally we get for a certain range of twist. If we increase the twist, this value will little bit change. This relationship, we must understand, this relationship is not the universal relationship. With a particular condition, this relationship works. Now let us calculate using this derived formula. The diameter of 44 tex cotton yarn is approximate. Diameter we have to calculate in millimeter. So this is the relationship we have derived. So we can just go back. So this was the relationship for centimeter. We can get it. This is 3.75 by 100 millimeter, and here text value was given 44 text. So if we under root 44 will become 6. Under root 44 will become 6.62, and the yarn diameter becomes 0.24. So using this relationship directly we get the diameter for any given yarn linear density. But this is the rough estimation, and let us see the yarn diameter in millimeter. So this is the direct formula. So with this, when we replace this English count 25, so we get value 0.182 millimeters. Now in textile industry or textile product, we normally don't use always the single yarn. Single yarn is definitely used for many applications, but for major applications we use folded yarn, or it's called plied yarn. Plied yarn is used basically just to improve the yarn characteristics as far as evenness is concerned or strength. So plied yarn is used from the final yarn, which is called folded yarn. If there is only one thread, then yarn itself is referred to as single yarn, or in a folded yarn the individual components are called singles. Okay. If we want to calculate the linear density, so depending on the count system being applied, the folding number appears in different count system. Okay. So in indirect system, the resultant count, it's in R, is the resultant count. So if you have say n number of components, so in reciprocal, you take the reciprocal of individual component linear density or count and then add. So resultant count we can get. So n1, n2, n3 not at the individual count. This is indirect system. In direct system, so first let us try to do a numerical. So assuming there is no twist construction, the resultant linear density in text of 440 NE folded yarn. So 4 yarns of 40 English count. So 1 by resultant count, 1 by 40 plus 1 by 40 plus 1 by 40 plus 1 by 40. 4 components are there. So 4 by 40. Okay. And in R will be 40 by 4, 10 NE. So initially it was finer yarn, as they are of all of equal linear density. So this yarn will be with 4 folding, the yarns become 4 times thicker. So initially individual component 40, it's a finer one. So 4 times thicker means it will become 10. Okay. So 4 ply, this is 40, and if we get, it will become 10 NE. Now what is asked? Linear density text. So this 10 NE we have to convert. So NT equal to 590.5 by NE. So 59.05. This is the text count. Okay, 59.05. So in this way we can go on solving different numerical. Now let us try to do another numerical. The length of 27 gram of 100% cotton yarn is 1000 yarn. Now this yarn is twisted with 20 NE 100% polyester yarn. So assuming there is no twist contraction, so we normally in this type of calculation we assume there is no twist contraction. If twist contraction is there, then the linear density has to be corrected depending on the amount of contraction. If it is contraction is more, then linear density become higher mass per unit length be there. So the linear density in text of this 2 ply, so this is in E is given, and second one we have to calculate the, so this is component 2. For component 1, what we know, NE1 component 0.54, as we have length in yard 1000 by weight in gram 27. So it will become 0.54 20 NE, and another component is 20. So 1 by in R equal to 1 by 20 plus 1 by 20. So in R will become 10. So, and 10 is the English count, and text will be in T is 590.5 as the relationship we know, NE. So 590.5 by 10, so 59.05 English count. Sorry, this is text count. So in this way we can solve different types of numerical. So you can see here, this is 59.05 text. In direct system, so this was all in indirect system. In direct system, we have to add to get the resultant. So for denier, so individual denier is N1, N2, N3, N4. So we simply add and to get this resultant count, because direct system is coarser the yarn, higher will be the value. Okay. Now try to see 45 nm worsted yarn, 130 denier polyester filament, 50 NE cotton yarn are twisted together. Assuming there is no twist construction, the resultant count of 3 ply yarn in text. So what we have to do, as it is asked for text, it will be better to convert it to text for all the linear densities. So worsted count, worsted yarn. So to convert it to text, first component worsted, so 1000 divided by 45 worsted value, so it is 22.22. Then polyester, it's 130 denier. So denier to text, the factor is 9, so 14 point, this is text, and cotton 590.5 by 50, 11.81 text. So for 3 ply yarn without any twist contraction, this will be simply addition of these 3 values. So for resultant yarn, 3 ply yarn, the text value will be 48.47 text. Another numerical, 2 yarns of 20 text and 1 yarn of 30 NE, 1 yarn 50 nm are twisted together to have 4 ply yarn. We are getting 4 ply yarn. So no twist contraction, and the text value of 4-ply yarn. So same way we can do. So 20 takes, so 4-ply, NT of 4-ply, 20 takes plus 20 takes plus any means 590.5 by 590.5 by 30, and the text value of NM, if we from the relationship we can get. So this is the NM, and so 1000 by 55. So if we just simply add, so this will become, this is becoming 18.18, this is becoming 19.68, and then 20 plus 20. So if we add, we will get 77.86. So 18.18 plus 19.68 plus 20 plus 20, 40 will become 77.86 ticks. Next numerical is 30 nm wool yarn and 60 NE cotton yarn, 120 denier polyester filaments are twisted together, no twist construction, resultant English count, that is N. So we can first convert it to text. Okay. So resultant text count is, so first is wool yarn, NM, so 1000 by 30 NM, NE, so denier is 120 denier for polyester filament, it has become 120 by 9, 13.33. For cotton yarn, cotton, it becomes 590.5 divided by 60, 60 NE cotton yarn, and then we simply add, it becomes 56.50. This is in text. Again we have to convert it to English count, so 590.5 divided by 56.50, it will become 10.45. So from all this numerical we see that we have to first convert it to from one system to another system, then depending on the fact that whether it's a direct system or indirect system, we can simply use the relationship. For direct system we can simply add. So the yarn measuring principles are the yarn linear density measuring principle. There are various methods available. We will not go in details of all these methods. Simply we'll see the two basic methods. One is that measurement of yarn system, an accurate value of the sample length and accurate value of the mass. So this we have to take and then from there we can calculate the yarn linear density. So yarns are available in two forms, so in continuous length form or in short cut length form. Okay. So if it is a continuous length form, so in that case we can take lee of certain length, longer length, say 120 yards lee we can take, and then we can take the mass, and accordingly we can count. But if the yarn is available in the form of fabric, suppose we want to measure the linear density of yarn taken out from fabric, in that case longer length is not available, so short or cut length will be available. For that we will not use the same method which we will be using for Lee counting, Lee count measurement method. So yarn in package form, we take out the yarn and form the Lee. Okay, so Lee of 120 yards, and then and using the wrap reel we use the make the Lee, and then we can take the mass and we will just convert it to count. So this is the wrap reel, where we have seen that we one wrap, one revolution, it is 1.5 yards. This is 1.5, and if we take 80 such wrap, it will become 120 yards, which is called Lee. And this Lee we take the mass in gram, and from there we can calculate using the formula which we have already discussed. So wrap reel and Knowles balance. So there are different methods available. So there's a Knowles balance is there, where for different counts we use this small Lee we take, and at present we have direct weighing balance, but in earlier days where weighing balance was not possible, electronic weighing balance, where measurement of the mass with a smaller mass was difficult. So here we can simply place the yarn specimen here and directly, and with the standard weight is placed for a particular count system, and directly from this scale we can get the value of yarn count for different range. So this scale is hexagonal in shape, and at different site it's a different range is available. This detail one can refer to different books available, so I am not going to discuss here. So wrap reel and wrap block. Okay, wrap block is used for linear density measurement of the roving, okay, or sliver. Quadrant balance system is also there. So depending of the here, what we do, we place the Lee here, and depending on the linear density, this the pointer will get deflected, and from this scale we can quadrant scale we can directly get the linear density value. We don't have to calculate. So these details are. Another thing, Beasley balance is there, where we have got very, suppose we want to calculate the measure the yarn linear density, yarn count of a very small fabric piece. So where we cut the fabric sample in this template, as per this template, like cotton, if we want to use a cotton, so you will cut the specimen in this size, this standard size, and here there is a mass, standard mass is placed, and we'll put the this yarn thread taken one by one, we'll put one by one here in this right side in the hook, and till this pointer is matched with the reference pointer. So if they are balancing, then we will simply directly count the number of threads, and that will give you the yarn linear density. So this was one method for the short length of the yarn when it's available. And we have come to the end of this session. Thank you.